How are you? Hopefully good. So today we have taken one question where a wooden plank is given to you. This is the wooden plank, and from here a bullet is just entering and just penetrating through the plank and exiting from the plank. Okay. So the question is that having penetrated a plank of thickness D, so the thickness of this wooden plank is given to you, and that is equal to D. Okay, this thickness is given to you, and this is nothing but D. D is the thickness of the wooden plank. Now from here a bullet just changes its velocity from v0 to v. That means during the entry the velocity of the bullet is given as v0. Here it's v0, right? And on exiting after penetrating, the velocity of the bullet is v, right? And the time of motion in the bullet plank, I mean to say we need to find the time of motion in the bullet into the plank. Okay, so during traveling this d, a time taken is t. Okay, so we need to find the what is the value of this time which is needed to when just it enters the plank and exit the plank. What is the time taken, right? it's given that it's given that assume the resistance offered by the plank is proportional to the square of the velocity of the bullet, right? That means as given as given, force is proportional to the square of velocity of the bullet, right? It's given to you. Now if you replace the proportionality constant, and since it's a resistance, this force is giving some resistance, so negative sign will be there, right? And if you remove the proportionality constant, let us say a k is introduced over here, so it will be minus kva square, right? If you read the question to the description, it's given that the bullet is following a giving a retarding force, right? And it's given that the resistance offered by the plank is proportional to the square of the velocity of the bullet. So f proportional to the square of the velocity, and since it's resisting, it's negative, right? Now f equal to minus kva square, because we remove the proportionality constant and k is introduced over here, right? We also know that f is equal to ma, Newton's second law, if you remember. So if you write in place of this f as equal to m into a, this will be equal to minus k into va square, isn't it? And this a can be written as dv by dt, because rate of change of velocity is your acceleration. So this can be written as m into dv by dt is equal to minus k times va square, isn't it? If this can be written like this, then we can rewrite it as, just bring the velocity into the other side. So just write dv by v square is equal to minus k by m into dt, isn't it? Now this can be written as v power minus 2 into dv, and it's minus k by m into dt, right? Now we need to integrate the LHS and RHS and see the variation. From the starting here, t is equal to 0. So let us take t equal to 0 to t equal to t, time taken to cross the plank, right? So here it will be t, right, from 0 to t. And the velocity varies. When the bullet enters, it was velocity of the bullet was v0, and when it exited it becomes v. So the lower limit will be v0 for this integration, and the upper limit will be v, right? Now from here, just solve it. So b to the power minus 2 can be written as b to the power minus 2 plus 1 divided by minus 2 plus 1, right? This will give you, and it will vary from v0 to v, right? v0 to v. Now from here, just into the RHS, we have minus k by m. If 1 is 1 of dt, integration of 1 is definitely the variable with respect to whom the integration is happening. So this will become t, and the value will vary from 0 to t, right? So this will give you v power minus 1 by minus 1 is equal to minus k by m into t. So just don't forget to keep the limits, okay? Because the starting velocity of the bullet and exiting velocity of the bullet is given to you, okay? So those are the limits. So t, from the t, when we put the upper limit it become t, and when we put the lower limit it becomes 0, right? Right? So it will be minus 1 taken as common, and it becomes b power minus 1. So when the upper limit will be there, b power minus 1 minus, here v will become v0, then it will become v0 power minus 1, right? This will be equal to minus kt by m, right? The RHS. Now this will give you when minus 1, it becomes 1 by v minus 1 by v0. Okay, we are going to calculate the time to cross the wooden plank, right? Is equal to minus kt by m, right? This can be further written as, so the time of traveling is almost calculated, right? That is, you can see 1 by v minus 1 by v0, right? When you just cancel out this minus, you can cancel out, right? And we have 1 by v minus 1 by v0 is equal to kt by m. So the time required to travel, just keep t into the RHS, and m by k here will become 1 by v minus 1 by v0, isn't it? M by k, 1 by v minus 1 by v0. This is the time of motion inside the plank. This is the time of motion inside the plank. Time of motion inside the plank, right? Time of motion inside the plank is calculated, but we need to do some changes. What is that? Let us see. So whatever we have derived, just put it over here at a single place. Okay. So the time of motion what we have derived is t is equal to, time of motion inside the plank is what we have derived, m by k, 1 by v minus 1 by v0. T is equal to m by k, 1 by v minus 1 by v0, right? This was the This was the derivation. So from here, due to the lack of space, I am just writing it over here, right? So time of motion inside the plank is calculated as m by k, right? T as equal to m by k 1 by v minus 1 by v0, right? So from here, okay, we can see into the question it has been given that assume the resistance offered by the plank is proportional to the square of the velocity, and having penetrated a plank of thickness d. So my dear friend, here d is not coming, d is not considered, this d is not considered. So what we will do, let us do one thing. Okay, what we will do, we know the just change the velocity into its component of x, displacement by time, you will get the component of d. Okay, so we know that v is equal to dx by dt, isn't it? V is dx by dt. If v is dx by dt, we know this, right? Then this v can be written as, so the from the initial relation here it was, you can see m into a is equal to minus kva square. Okay, this we have equated the force as equal to the resisting force relation minus kva square. The resistance offered by the bullet is proportional to the v square. So minus kva square was there, k was the proportionality constant, and f was equal to ma. So we use this relation ma equal to minus kva square, right? So we will write it again, m into a is equal to minus kva square, right? If ma is equal to minus kva square, I am writing this line, right? I'm writing this line. So if ma is equal to minus kva square, this a can be written as m into dv by dt, isn't it? This a acceleration can be written as dv by dt is equal to, just we are going to introduce this d, the thickness of the plank, minus k, we already calculated the time to cross the wooden plank, that is m by k 1 by v minus 1 by v0. Now minus k times v square. Now this v can be written as, just write dv over here and 1 by dt over here, right? We can introduce dx over here, right? Dx into the denominator, dx into the numerator. This will cancel out and it will become dv by dt, which was our previous step, right? Is equal to minus k times v square, right? Minus k times v square. Now from this step you can simply write m into, you can just see v square is there into the RHS, just bring this over here into the LHS, right? Because dv is there into the LHS, we need to do the evaluation of v square with respect to dv, right? So it will become, just keep other terms into the other side of the equation, right? So here you can see dx by dt is also equal to what? It can be written as m into dv by dx, and dx by dt is equal to v. You can see here dx by dt is equal to v. So that's why if this dx by dt can be written as equal to v from here, right? We can write m into dv by dx into v is equal to minus kva square, isn't it, my dear friends? Right? So from here dx by dt replaced as v using this, and we can write m into dv by dx into v is equal to minus kva square, right? Now this can be written as this one of the v and this v square one of the v from v square will be cancelled out, right? And we have m into dv by dx is equal to minus k times v, right? Now from here, just you can need to differentiate v with respect to, so v should come along one side, so it will become dv by v is equal to minus k by m times dx, isn't it? What we did, we just kept all v in one side and other terms into the RHS. Okay, so it will give dv by v from minus is equal to minus k by m dx. So dx is the derivation, the small length varying from 0 to d. Okay, this is d, capital D. So from here, what we can write, that yes, this x is varying from 0 to d, and v is varying from v0 to v, right? So when we integrate it from v0 to v will be the upper limit and lower limit and upper limit. Okay, and here dx, the dx is there, so the distance is varying from 0 to d, right? So it will vary from 0 to d. We are doing all this just to introduce the d variable over here into the time to cross the plane, right? So this will be give 1 by v of dv, that means ln of v with v by v and v0 are lower and upper limit, right, is equal to minus k by m dx of a single constant will be equal to x, right? Integration will be x and it will vary from 0 to d, right? This will give you, when you put the lower limit and upper limit, it will become ln of v minus ln of v0, right, is equal to minus k by m into the value of x from d to d0, that is simply d minus 0, right? D minus 0. This will give you ln v minus ln 0. If you remember, ln is for base e. Ln v by ln v0, that means ln of v by v0. It can be written as ln of a by b equal to ln a minus ln b, right? We use this is equal to minus kd by m, right? So here you can see a relation is derived. So minus kd by m is the value. So from here you can see we need to find m by k. So from here just replace m by k. So it will become m by k. When you just bring here m to the LHS and k to the LHS, m by k will be equal to minus d divided by ln of v by v0, isn't it? Minus d divided by ln of v by v0, isn't it? Now this will give you since minus sign is there, okay, we can write it as m by k as equal to ln of v by v0 is there, right? So minus sign is there, so no need not to do it, just simple put it as it is. Okay, put it as it is and just put the value of m by k from here into the time. Okay, so here we have t equal to m by k 1 by v minus v0. So the time will be this time, the same formula which we have derived is equal to, the time is equal to m by k. Instead of m by k, write minus d divided by ln of v by v0, isn't it? Ln of v by v0. We just replace the value of m by k into this formula, m by k. Okay, the same. Multiplied by 1 by v minus 1 by v0. So it will be 1 by v minus 1 by v0, right? 1 by v minus 1 by v0. So the time taken by the bullet to cross the wooden plank is, in terms of this distance d, is given by t equal to minus d by ln of v by v0 into 1 by v minus 1 by v0. We can do further dressing of this. When we do further dressing, that means this minus can be introduced inside the bracket, and this time period t can be written as d divided by ln of v by v0, right, multiplied with, when you just minus sign is introduced inside the bracket, it will become 1 by v0 minus 1 by v. So my dear friends, this is the entire solution in front of you. Okay, this is the entire solution in front of you, and here you can see the time is calculated, and it is equal to it is just d by ln of v by v0 into 1 by v0 minus 1 by v. So this is our answer, my dear friends, right? This is our answer. So if you want me, I can read out the question again. The question was that, having penetrated a plank, this is the plank, having penetrated a plank of thickness d, thickness of the plank was d, bullet changes its velocity from v0 to v. You can see starting and entering and exit point of the bullet, and the velocities are v0 and v, right? And the time of motion of, find the time of motion of bullet in the plank. That means till what time the bullet is there. The question was asked, what is the time of motion which we have calculated t equal to, right? So this was the question to us. What was the time of motion of bullet in the plank, assuming the resistance offered by the plank is proportional to the square of the velocity of the bullet. So here, force, that means the force offered by this plank is proportional to the square of the velocity of bullet. We have taken this, replaced this proportionality constant with k, right? Minus kva square is there. Now F can be written as ma, a can be written as dv by dt. Now the variation of v is varying from v0 to v. You can see v0 to v, and t is varying from 0 to t because the time. Okay, just do the integration. We bring out the time, and time is calculated as m by t, my dear friend. So this will give you, when you just evaluate, this will give you the time with m k in terms of mass, in terms of proportionality constant k, velocity v, and v0, right? So all this will give you the time. Now the t can be written as m by k 1 by v minus 1 by v0, and v can be written as dx by dt. So what we will do, as we have derived the relation ma equal to minus kva square, which is given as per the question. So ma equal to minus kva square is taken over here, and a can be written as dv by dt, and v can be written as dx by dt. So that's why we introduce dx over here. Here dx is introduced into the numerator and denominator, right? And this will give you dx by dt is nothing but v, and here this v will cancel one of the v from the RHS, right? And finally this will give m into dv by dx equal to minus k times v, and you can see just bring all v in one side, so it will give dv by v, and into the other side minus k times m into dx here, right? So v is varying from v0 to v, and x is varying from 0 to d, because this is the v0 velocity of the bullet starting from v0, this is the beginning, right? And this is the exit velocity, right? So this will just put the lower limit and upper limit and just solve it. You will get the time period of the bullet inside the plank of thickness d, right? This will be equal to d by ln of v by v0 into 1 by v0 minus 1 by v, my dear friends, right? This solution is very much clear. Now, whenever if you just derive this, need not to remember, if this derivation is coming is just asked into the question, you can just derive this, and now just whatever the value of thickness of the plank, just put it over here in place of d. V and V0, when the velocity of the entry point and exit point of the bullet is given to you, just put the values over here. You can easily calculate the time. Whatever be the thickness of the plank, you can easily calculate, my dear friends. Easily, right? Because you derived the formula. From this formula, just put up the value of D, find the ln of V by V0. You are knowing V0 and V, right? So finally, my dear friends, I think it's understandable to you. If you want me to explain, I can explain again and again and again. But hopefully you understand it. Any query, just let me know into the chat box. And yes, my dear friends, be connected. It's very good connecting with you. I think this is a good question I thought to bring in front of you, and how the steps are varied I explained you. Okay, if you want me I can explain again, but yes, any query don't hesitate to put up into the chat box. I always welcome your comments. Okay, those certain, yeah, no problem. Yes, I can get it. Yeah, so I think you got it. So this is the formula which we derived and we have taken it here. Okay, so right, what we derived, t equal to m by k 1 by v minus 1 by v0. What is wrong into this formula is also correct, this formula is also correct, but there is no d over here. Okay, so just to introduce d, this one, the thickness of the plank, just to introduce d, what we did, we just used dx by dt for v, right? And through this, the relation ma is equal to minus kva square, right? So here a can be written as dv by dt, and dx can be introduced into the numerator and denominator. So dv by dx can be written over here, and dx by dt is v. This v will be cancelling one of the v, and finally we will get a relation of in the form of dv and dx, right? dv and dx, mind it, it's dv h dx. Now just bring all v terms into the LHS, it will become dv by v, right? And into the RHS equal to, it is equal to minus k by m into dx, right? Into dx, this one, this dx, right? Now this v 1 by v, the integration of 1 by v is given a ln of v, right? So ln of v, and what is the values of v varying from what to what? This varies from v0 to v0 to v, because v0 is the starting, the velocity of the bullet during entry, and v is the velocity of the bullet during exit the plank, right? So that's why v0 and v is considered over here. And here you can see dx is the, this is dx is for the displacement, or d, the distance, right? So it's 0 to minus d, because when the at the starting, when the bullet is entering the plank, the thickness of the plank is 0, but when it exited, it covers a distance of d. Okay, so that's why 0 to d is considered over here. Okay, this is the lower limit, this is the upper limit. Now we simply 1 by v, integration of 1 by v is ln of v, and it's v0 to v, just put up the upper limit and subtract with the lower limit, you'll get it ln v minus ln of v0 is equal to minus k by m into d minus 0. This will give you ln v minus ln a minus ln b can be written as ln a by b. So similarly we have written ln v minus ln of v0 ln v by v0, right? This will give you minus k by m into d minus 0. D for the upper limit is considered and 0 for the lower limit, here this one, right? So finally we get a relation, we get the value of m by k into the terms of distance, that means the thickness of the plank was d, and we get m by k as minus d divided by ln of v by v0. Now into this formula for the time only d was missing, so we had replaced this m by k with this one, right? What we have derived, that is d by ln of v by v0, and this negative sign is compensated inside the bracket, and it will become, instead of 1 by v minus 1 by v0 into the bracket, it becomes 1 by v0 minus 1 by v, my dear friends. So thank you so much for watching. Be connected, happy learning, take care, see you again into the next class, my dear friends. Thank you, bye bye, see you.